Now that we've seen a little bit more about triangles, we can tidy up a couple of loose ends in terms of angles in them. And we can use that angle rule to do a couple of questions. So here in this question we have a triangle given to us with corners A, B and C. Two angles are marked. There is a 64-degree angle at A and a 32-degree angle at C. B is left unmarked. And the first part of this question says work out the size of the angle ABC. Well, first thing, what on earth does that mean? ABC. Here's how angle notation works. You start at the first one, i.e. A, you travel to the second one, and then you travel to the third one. So we go from A to B to C, and the angle at the middle one, when going from A to B to C, the angle at the middle one, when going from the first to the second to the third, is the angle we're looking at. So we want the angle at B when we go from A to B to C, i.e. this one here, which helpfully is marked for us and is kind of the one we were expecting anyway. How do we do that? Well, we work out the size of the angle by using that fact about triangles that the angles in any triangle will add up to 180 degrees. So I'm going to do 64, I'm going to add on the 32, and that's going to give me 96 degrees, and then I'm going to do 180 less than 96 to give me 84 degrees as my answer. Looking at that angle at B, that seems reasonable as an answer. B looks kind of close to a right angle but is still an acute angle. 84 degrees seems reasonable in that. Give a reason for your answer for part B. Well, we just need to write down the fact that we've used, and the fact that we've just used is angles in a triangle add to 180 degrees. So we just need to write that down. ABC is an isosceles triangle. Work out the size of the angle marked X. Well, the key word in that question is isosceles. We should actually be able to work that out from the diagram. If we just look at the diagram, we should notice these two lines here. And in fact, with these angle problems questions, we are going to train ourselves to look at the diagram first before we look at the words, so that we can really unpick exactly what we need from the diagram. If we look at the diagram then, we've got these two dashed lines, and we know that that dash means that two lines are the same length. If we have a triangle here and two of the sides are the same length, then it must be an isosceles triangle, so the wording just confirms what we could actually get from the picture. We're given an angle 65 degrees, and we've got to work out the size of the missing angle X. Problem is, we've got two angles in this triangle that we don't know, but it all hinges on the fact that it's isosceles. Now, with it being isosceles, two of the angles are the same. We need to work out which two. Well, to work out which two, step one, we point to the two sides that are the same length. Step two, we point to the angle where they meet. That happens to be X. The other two angles are the same size then. So the angles at B and C are the same size, which means step one, because we are going to give reasons for this even though the question doesn't need us to, this angle here must be 65 degrees. Why? Because it's an isosceles triangle. We don't really need to give anything more fancy than that. It's an isosceles triangle, therefore those two are the same size. Step two then, we should be able to work out the value of X. Well, we can do 65 plus the 65 is 130, and then we can do 180 less the 130 is 50 degrees, and A, or X rather, will be 50 degrees. Why? Should probably give a reason, even though we don't need to for this question, but again, we're training ourselves to give those reasons, to really think about why we're doing what we're doing. What fact have we used? Why have we taken away from 180? Well, because angles in a triangle add to 180 degrees. But notice that we've done two steps here, so if we were having to give our reasons, we've justified it with two explanations. The first one to say how we knew that angle was 65 degrees, because it's an isosceles triangle. The second, why have we taken those both away from 180 degrees? Because angles in a triangle add to 180 degrees.